Hey guys, we're continuing talking about the functional anatomy of the respiratory system. We left off with talking about the trachea, so now we're going to move on to the main bronchi. So the right and left main bronchi are formed by the division of the trachea. So here's your trachea, and these are the bronchi, the little branches basically. Each main bronchus runs obliquely before it plunges into the medial depression of the lung on its own side. The right main bronchus is wider and shorter and straighter than the left. So here's the main bronchus. It is wider, you can kind of tell. It's kind of hard to tell from this picture. It is the more common site for an inhaled foreign object to become lodged. By the time incoming air reaches the bronchi, it is warm, cleansed of most impurities, and well humidified. And the smaller divisions of the main bronchi within the lungs are direct routes to the air sacs. So these right here, the little branches basically. So you got the trachea and then the main bronchi. The right one's bigger, remember, anatomical position. So even if it's our left, it's the person's right. Okay, lungs. So the lungs occupy the entire thoracic cavity except for the mediastinum, which houses the heart, the great blood vessels, bronchi, esophagus, and other organs. The narrow superior portion of each lung, the apex, is just deep to the clavicle. And the broad lung area resting on the diaphragm is the base. Each lung is divided into lobes by fissures. The left lung has 2 lobes and the right lung has 3. You can't really tell from this picture. The surface of each lung is covered with a visceral serosa called the pulmonary pleura, and the walls of the thoracic cavity are lined by the parietal pleura. The pleural membranes, so this is a better diagram here. Here's the pleural fluid. Here's the diaphragm here. So the pleural membranes produce a pleural fluid, which is a slippery serous secretion which allows the lungs to glide easily over the thorax wall during breathing movements and causes the 2 pleural layers to cling together. So the pleura can easily slide from side to side, but they resist being pulled apart. This is pleural fluid here, and this is the pleura. The lungs are held tightly to the thoracic wall, and the pleural space is a potential space. So this condition of tightening or tightly adhering pleural membranes is essential for normal breathing. Pleurisy is inflammation of the pleura. It can be caused by decreased secretion of pleural fluid. The pleural surfaces become dry and rough, resulting in friction and conversely, the pleural may produce excessive amounts of fluid, which exerts pressure on the lungs and hinders breathing movement. After entering the lungs, the main bronchi subdivide into smaller branches, finally ending in the smallest of the conducting passageways, the bronchioles. Because of the branching and rebranching of the respiratory passageways within the lungs, the network formed is referred to as the bronchial tree, which kind of makes sense because we were talking about branches before. The terminal bronchioles lead into respiratory zone structures, even smaller conduits that eventually terminate in alveoli or air sacs. So going back a few slides, this picture right here is a picture of the alveoli. These little branches here are the bronchioles, and they kind of they lead into the alveoli or air sacs. Same thing. The respiratory zone, which includes the respiratory bronchioles, alveolar ducts, alveolar sacs, and alveoli, is the only site for gas exchange. So all the other respiratory passages are conducting zone structures that serve as conduits to and from the respiratory zone. There are actually millions of the alveoli, which look like a little bunch of grapes, that make up the bulk of the lung. So the lung is mostly air spaces because alveoli are these little air sacs, and if there's millions of them and they make up the lungs, then the lungs are mostly air spaces. So the lung tissue, or stroma, is mainly elastic connective tissue that allows the lungs to recoil passively as we exhale. The lungs only weigh about 2.5 pounds and are soft and spongy, in a healthy lung at least. The walls of the alveoli are composed of a single thin layer of squamous epithelial cells. Basically, a sheet of tissue paper is thicker than the wall. It's pretty crazy. So they're very, very thin. So here's the alveoli, here's the bronchiole, and once again, trachea, bronchus, right here, and then the bronchiole is like the little tiny branches, and then the bronchiole branches off into little clusters of grapes or air sacs called alveoli. So the alveolar pores connect neighboring air sacs and provide alternative routes for air to reach alveoli, whose feeder bronchioles have been clogged by mucus or otherwise blocked. The external surfaces of the alveoli are covered with a cobweb of pulmonary capillaries. So you can kind of see that from this picture. These are the capillaries that's covering them. The alveolar and capillary walls, their fused basement membranes, and occasional elastic fibers construct the respiratory membrane, or the air-blood barrier, which has gas flowing past on one side and blood on the other. So the gas exchanges occur by simple diffusion through the respiratory membrane, oxygen passing from the alveolar air into the capillary blood, and then carbon dioxide leaving the blood to enter the gas-filled alveoli. The total gas exchange surface provided by the alveolar walls of a healthy man is 50 to 70 square meters. So that's 40 times greater than the surface area of the skin. So it's pretty crazy. The final line of defense for the respiratory system is in the alveoli. So there's alveolar macrophages that wander in and out of the alveoli. They pick up bacteria, carbon particles, and other debris. And scattered within the epithelial cells are chunky cuboidal cells which produce a lipid molecule called surfactant, which coats the gas-exposed alveolar surfaces and is important in lung function. All right, here are some questions. What is the order of the following parts of the human respiratory system from the site where air enters the nostrils to the site where air reaches the end passages of the lungs? And then they give you bronchi, larynx, nasal cavity, alveoli, trachea, pharynx, and bronchioles. This is important. Make sure you know this. So it goes nasal cavity, pharynx, larynx, trachea, bronchi, bronchioles, and then alveoli. Which main bronchus is the most likely site for an inhaled object to become lodged, and why? That's the right one because it's wider and straighter. And the lungs are mostly passageways and elastic tissue. What is the role of the passageways? And what is the role of the elastic tissue? The passageways conduct air, and the elastic tissue allows lungs to recoil passively when exhaling, saving energy. Okay, and name the 4 structures that make up the respiratory zone. There's respiratory bronchiole, alveolar duct, alveolar sac, and individual alveoli. I believe that's it for today. Yeah, starting tomorrow, we're going to start getting into the physiology of the respiratory system.